So, what are you doing? All right. So, first half, if you were really intense and looking at the ACARA, that's the national curriculum that we have to look at. They talk about, we have to mention the unit circle. Some years we don't get to it. It's really, this is the best bit, I think, about trigonometry. Like, this is the bit that really excites me. Unplug your... Okay, it's fascinating. I know that, but I can't tell. So it's fascinating, right? And I hope you find it fascinating, and it's a lot of interest, and it puts, I'd like to think, trigonometry into a bit of perspective and some of the how come. So with your calculators, you do not have to write any of this down. All right, no writing. We're just doing, because we're going to pop it on the yellow sheet in a momentito. So with your calculators, we are, you know, you did this sort of thing in year 9. If we've got sine theta equals a half, so why looking up here, please? I'm talking, pointing at the board, and you're looking at your screen. So if I've got sine theta equals a half, we would all know to get rid of that sign, we inverse sign, good language, excellent, right? Take the inverse. So do that on your calculators. Sine to the minus 1 of a half. And what do we get? And you know, I've just asked people to do that. I've got some who aren't touching their calculators. I've got you who haven't got one in front. So for people playing at home, they're looking at me going, oh, my calculator's dead. So you've never been in this classroom where people have gone and got a calculator. Organise yourselves. So what's the point that I'm trying to make? Well, no point yet. Oops. Here comes my point. So if you now go sine 30, what do we get? We should get a half. What about sine 150? What do you get? How come, though, that didn't come up? Tom, you keep typing. We're going to have an issue. When we go along with this, we get sine 150. We get a half. What about when you go sine 390? Ooh. And sine minus 330. Half. But how come when you go sine to the minus 1 of a half, you only get the one solution? And yet I'm showing you there's 1, 2, 3, 4 values for theta, for that angle that you can pop in, sine it, and you get a half. And guess what? There's a whole lot more. What you would have to do, and what my year 11s and what they're asking us to do at year 10, but I'm not going to assess you on this as long as you complete this little sheet. How do we get, or why do we have more than one solution for sine theta is a half, right? No longer should we accept that there is only one solution. Do we get that? So this is going to tell you in a moment why there is going to be more than one solution. And just to force myself now and show off a little bit, if you go sine 45, don't tell me, but people with graphic calculators, it will tell you that that's root 2 on 2. Agreed? People with scientific calculators would be like 0.707 something. Right, sine of 135 will be 2 root 2 as well. And then you're going, oh, I know what she's going to do. It's going to be 2 root 2. No, it's not. Sine of 225 is going to be minus root 2 on 2. And sine of 315 is going to be minus root 2 on 2. Check it. Don't just trust me. Is that the case? And some of you might be going, oh my God, she just remembers everything. No, I don't. And you will be able to tell me this stuff shortly. It's really simple. Like, it looks like it's magic, but it's not. Okay, same with cos of 45. Check that out. I know that that's root 2 on 2. And you guys have seen me. My memory is a little bit shocking the older I get. And yet I've still got that under control. And cos of 135, again, no calculator up my sleeve. That's not going to be root 2 on 2, but it's going to be negative root 2 on 2. Okay, cos of 225 in my head, I am picturing, oh yeah, that's going to be minus. And this one will be positive, right? Again, don't just trust me, but check. So it's all got to do, believe it or not, with circles. What? We're talking about triangles. Where have circles come into it? we'll show you in a minute. So now we're going to get that yellow piece of paper that you've got in front of you. People playing at home, that's the white unit circle intro on Daymap. And we should see this graph on your sheet with a pen. I know, you can use a pen or you could use a pencil, up to you. We're going to start here and we're just going to go, so this is 0, then that goes 15, 30, 45. It goes up by 15 degrees all the time. You probably can get 60, 75. After that, you can probably just do up by 30s. But I just want you to see what's the shape that you're going to get. So pretty simple. We grab our calculator and we just go, what's sine of 0? And 0. So when sine is 0, what's this y-axis? We put a cross there as 0. Pretty simple. We then go back to our calculator. We go sine 15. Oh, good Lord, look what happens. I just press S to D. Okay, 0.258. Yeah, it doesn't have to be exact. So this would be 0.1, 0.2, 0.3, and so on. So 0.258, do you reckon it's about there? We put a cross. Sine 30, we don't have to go to the calculator because we already know that one. Do we agree? Sine 30 is 1/2. We should know that one. Okay, sine 45, we did that one too, but let's remind ourselves, so 0.7. We pop, so 5, 6, 7, put a little cross there, getting the gist? Okay, and once you've done this, you'll see why after you've got to 90, you might not have to do every 15, you might just go 30, 30, 30, all right? And then I'm going to ask you to connect the dots. Go. So people have plotted that and they've realised that that's what the graph looked like, and they didn't even have to like pop every single point. They got the gist of what was going on. They realised there was some patterns going on. What would you say about, I mean, look at 30 and 150. Remember we talked about that? They were both 1/2. Can you see how they're sort of reflections of one another? And so here's 60, whatever that was like √3 on 2. Its counterpart over here, I reckon 120 would also be √3 on 2. So they've got this mirror image going on. Oui? Where does that come from? I'm glad you asked. Oops. Where does it come from? So, when I said at the start of the lesson, we're going to be looking at circles. Your sine graph is actually the height when you're moving around a circle. Right? So if we started here, which is where we're starting, this, and let's imagine that that's 0 degrees, this will be 90, 180, and so on. Ooh, stop. It's starting here and it's going around. I need to stop. Oh yeah, I can stop it. So when it starts here, right, it's actually plotting the height of that particle. So over here, the height is 0. So that's why over here, that's where we will get 0. Yeah? And then, as it goes up, what's happening to this height? It's getting higher and higher and higher. When does it hit its maximum of 1? 90, that's where you got here. 90, it had its maximum of 1. And then, when it is moving past 1, past 90 degrees, what's happening to the height? It's going down, right? That is why it started going down. Do we get that? But it's traveling around the circle. And of course, what happens when it passes 180 degrees? What's happening to the height? It's now getting negative. So let's just, how did I play that? Oh, I want it to go here. It'll go, I think. Oh. Should have left it where it was. Here it goes. It is quite satisfying. And so you can see it just keeps on going and going and going, right, forever. So this was when the particle's going around the circle and we're looking at the vertical height. What about cosine? What do you think that's going to do? Pardon? The middle. What do you mean the middle? Where it hits 0. So go on your calculators and go cos of 0. What do you get? You get positive 1. So it's not graphing how high it is, but it's actually looking at horizontally. So here, can you see how it's 1? So cos 0 starts here at 1, so it's going to start upstairs. And then as I'm moving around the circle, what's going to happen to this? It's going to start going down. So it's going to have 1, and then it's going to go down. Shall we click it? Ooh, I should have clicked it when it was at 0. Missed it. Wait. It'll come. So when it suddenly comes around here, it's going to start here and go down. Ooh, here it comes, here it comes, here it comes. Ooh. But it's basically, you can see how it's traveling, that particle's traveling around the circle, and it's graphing its horizontal distance. Does that make sense? I mean, you could keep watching it go on and on and on. And what do you want me to press? Anyone want to have an idea, a guess of what tan is going to be? You think it'll be in the middle? Ready? I'll have to wait till it comes around here, and then I'll press it. Tell me when to press it. Ready? What's going on? Who said that? It's measuring both. You are close when you're saying they're both. Tan is actually a combination of sine and cosine, right? It's not adding them together, but we'll have a look at that. But that is, I just find that quite satisfying. I like to look at that. It keeps filling in the... Anyway. Sine and cosine are actually connected, and it's connected by tan, and tan theta is actually sine theta divided by cosine theta. Right, and if we take it right back to our basic rules, what is the rule for sine theta? Like, what was it? OA and H, which one? What was the rule for sine? Right, so sine we knew was opposite over hypotenuse, and cos is adjacent over hypotenuse. And what was tan? Opposite over adjacent. Just sort of going, oh, these are the rules. Well, look at this. Sine theta, we've said, is opposite over hypotenuse, divided by cos theta is adjacent over hypotenuse. When we're dividing by fractions, how do we divide? We replace the divide with a times and flip. Well, the h's will cancel and we're left with O over A. So there's all these things that tie them together, right? And you go, oh, is that why? Or you might just go, yeah, well. And coming back to, take here, I mean, why have we got this crazy business here going on? Right? Yeah, it just keeps going because I haven't worked out how to stop it. So on your calculators, can you go, what's tan of 90, please? Go tan of 90. Right, it's error. It's undefined. So why is that? Because your red graph is cosine, right? What's cosine at 90? Can you read off the graph here? It's 0. So when we come back to here, we're saying something divided by 0. Can we divide by 0? No. So whenever cosine is 0, that's why we get these, whoosh, they're called asymptotes, but don't worry about that just yet. But we actually say it's undefined, okay, at 0. So that is why tan looks like that. It's dividing your sine value by your cosine value. All right. When we come now to our circle, this is what you are going to play with. So as we said, because that particle is moving around, when you are measuring the vertical axis, sorry, this one, this is what's measuring sine. Would you agree? And we said the horizontal cosine. So that means any coordinate around here, go back to your year 9 days, any coordinate is x value first, then y value. Yep. So on our things, instead of our being an x, that's actually cos theta sine theta. So at 0, what's cos of 0? 1. What's sine of 0? 0. So that fits with that point on our, like if you had a circle, actually don't even have a circle. If you just had the axes, right? We're looking at this point right here. This is 1. What is that point? Isn't it 1, 0? So that's what this coordinate is, 1, 0. But that's my cosine, that's my sine. That sort of makes sense? This one is 30. What's cos of 30? We know sine of 30 is a half, and if you look, right, this is a big fat old 1 there. That looks like it's halfway, doesn't it? What's cos of 30? It's a number that's going to be closer to 1. 0.86, whatever. Now, those with graphics calculators, what is sine of 30? Root 3 on 2. So, does anyone want to have a guess what this coordinate would be now? So, it's the same distance that way along the x-axis, isn't it? But it's negative. So, negative root 3 on 2. What's its height? Half. Yeah? That's come up here by 30. So, this is now come back by 30. So, what degrees would that be, do you think? 150. So, what we're saying here is cos of 150 should be minus root 3 on 2. Pop it in your calculator. What is cos of 150? Press it in your calculator. Is it minus root 3 on 2? Or minus 0.806 if you've got a scientific? And what is sine of 150 going to be? Half. Who wants to tell me what this angle would be here? 210, because you've added on 180 plus 30, right? 30, yes? Who can tell me what this coordinate is without using a calculator? So it's still coming, minus, everyone get this? We're coming across, so it's minus root 3 on 2. And how far down have we got? Like these are minus a half. So guess what cos of 210 is? Negative root 3 over 2. Guess what sine of 210 is? Check it on your calculator. Don't just believe me. So can you see that this point, this point, this point, and this point are connected? Yeah? So if you think you can fill out the other point, you go for it. So this has gone the same distance across here. So wouldn't that be the same value? So that's going to be root 3 on 2. But how far down has it gone? It's gone down the same height that it's gone up that way. So negative a half. And I know that this angle is 30. So I've gone 360, but I've come back from 360. So what's that? 330. So because every point has your x value first, then your y value, and we're saying our x-axis is actually cosine, what we can say is that means cos of 30 is root 3 on 2. And, and sine of 330 is negative a half. Grooves? Now, here comes the next bit. What about these points? We'll leave 45 for the moment, but what about these ones here? Can you see they make a nice little rectangle? But hopefully when you were doing your sine graph, you saw that there were some repetitive values. Without going to your calculator, anybody want to have a guess? Look at this where does that cut your x-axis there? Like that's 1. It's sort of in the middle, isn't it? That's your cos value. So do you reckon that's a half? And how far up do you think it's gone? It's not quite to 1. 0.8, which is root 3 on 2. Check with your calculator if you don't believe me. Mia, I'm going to you, right? 90 back by 30 gave you 60. So now I'm going to go forward. So you're happy that 90 plus 30 gives you the 120. So what do you think this coordinate would be? How far have I gone that way? But now I'm going. Mia, you're echoing. That's excellent, yeah? Negative a half. And how far up have you gone? What's your height here? Root 3 on 2. So again, without a calculator, we can now say that cos of 120 is minus a half. Sine of 120 is root 3 on 2. Can you have a go at filling out these? So fill out the angles, not for the 45s yet. Fill out the angles here and fill out your coordinates. Go. Hang on, yeah, we're coming. So that was Tom, just visited. That was lovely. Sorry if the colours are, sorry about the colours going nuts. Go back to black. Now, one of my little handy tips, you don't need to worry too much because you have your calculators, even though JP in front of me has got his scientific, but in my day, this is what we had and we never got these exact answers. Your calculators give them to you, right? We used to have to remember it all. So you do this little triangle, and I ask my students, just remember one thing. Remember that sine 30, shh, can you listen to this? This is crucial. Again, I could ask Tom, the triangles, loves them. Even though he had the calculator, loved it. So remember one thing, sine 30 is a half. So, ready? Sine is opposite over sine. Opposite over hypotenuse, right? So now, using Pythag, 2 squared take 1 squared is 3. That's got to be root 3. And now, I get all of my combos. Why have you shaken your head there? 30 and 60. You ready? We know that one's 1 over root 2. What's cos of 30? Adjacent over hypotenuse, root 3 on 2. What's tan? Opposite over adjacent. Go tan of 30 on your calculator. Is it 1 on root 3? Yeah, you can't tell. Ah, yeah, root 3 on 3. That's the same thing. Go 1 divided by root 3 and press equals. And it gives you root 3 on 3. Same thing. That's maths. You're not allowed to have a... Yeah? Yeah, same deal. So 1 on root 3 is the same as root 3 on 3. And in a minute, you're going to see 1 on root 2 is the same as root 2 on 2. So, we want to finish this off. Would you like to, on your calculators, please, suss what is cos of 45? Someone has to, with a graphic, has to tell JP. Root 2 on 2, JPB. And what's sine of root 2 on 2? Oh, what's sine of 45? Root 2 on 2. So, who's going to play? Taya. Who can tell me what this coordinate would be? Wow, you said that without moving your lips. And you said it in Ollie's voice. Correct. Negative root 2 on 2. And what was this one? Root 2 on 2. And so what that's telling you is 90, so plus 45. You can now tell me without using your calculator, cos of 135 is negative root 2 on 2, and sine of 135 is root 2 on 2. Unit circle, people. So, can you fill out this and fill out this table, please? So JPB was just saying, this is important, why, excuse me, sorry guys, interrupting, but JPB was just saying, why is this so important? Because it's what we started with by saying, right at the beginning, when I just asked you, sine theta is a half, what's theta now? Up until this point, you would just go this, and you go, well, that's the only answer that's possible. But now, what this is actually showing you is that when we've got this half, yes, this is the answer that your calculator gives you, right, the 30, but that is not the only answer. There can be more than one solution. And in year 11, you will be asked, give me the solutions when it's between this point and this point, when it's between, Give me an expression for all of the solutions. And that relates to things that have periodic movement. Can anyone think about something that goes like a wave? The waves, tidal movement, absolutely. Okay? Things going around in a circular motion, Ferris wheel, music. This is all related. So, believe it or not, a lot of the music machines and stuff do stuff with how do you work out the tones. So it has a lot of applications for things that have periodic movement. You have got time to confab with your partner, your friends, anyone in the room, but it is not just, oh, this is now assignment time. No, 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 no. So I don't want to see your assignments out for long versions. You've got a little bit of time to just, if you know already, you should have looked at the questions and gone, I need help with this. Yes. Otherwise, you are doing your revision. As Tom said, the more questions that you do, the better off that you're going to be. That makes a difference between an A student, a B and a C.